Hello all. Let us see how to solve this particular problem. The statement is that there is a by D converter, and then the input is an analog value which is 0 to 5 volts, and then the output is a 10-bit digital value. So in this scenario, what is asked is basically what is the minimum value of ripple that should be there on the DC supply voltage. Okay, so how to solve this problem is basically the amount. This is the DC supply voltage. Okay, in analog voltage basically, and this analog voltage would be based on the DC supply voltage. So any variation on this DC supply voltage or the analog value would result in variation of this 10-bit. Now how this A by D works is, here it is 0 volts, and then this is 0, this is 5 volts. Okay, this is the total range of this analog input, and now this is represented by 10-bit. That means 0 0 0 so on up to 10 zeros, and 1 1 1 1 so on up to 10 ones. So this is nothing but 0, this is nothing but 1 0 2 3. Okay, that means in between 0 to 5 volts the values are represented by 1024. So each section in 0 to 5 volts is divided by 1024 values, so on up to 1024. Now what is the minimum value at each variation is given by 5 by 1024, which approximately gives to 5 millivolt. Okay, now that means each variation here will be 5 millivolts, and again from here to here will be 5 millivolts. That means in total this is 10 millivolts, 15 millivolts, 20 millivolts. Similarly it goes on up to 5 volts. Okay, so if there is a ripple on the supply voltage, what happens is, let us assume we want to represent this number 0 0 0 so on. The last LSB bit will be 1 for 1, and then it will be last two LSB bits would be 1 0 for the next number. Now let us assume I want to represent this value. So the value should always be less than or equal to 5 millivolts, such that I can represent this value. Now let us assume there is a ripple and the value goes to 6 millivolts or 7 millivolts. Then in this case what happens is, it has exceeded this, and this will be read by the A by D. So that means the minimum value of variation, that means the voltage variation would be 5 millivolts. So just to explain again, the ripple voltage is nothing but, let us assume there is a DC supply of 5 volts. Generally there will be some AC noise that will be introduced onto this. So in reality, when you capture the signal in an oscilloscope, it looks this way. So the peak to peak voltage variation here from the lower side of this AC, small AC component, to the top side is called the ripple voltage. So now here, as per our this one, it should not exceed 5 millivolts. So if this exceeds 5 millivolt, instead of representing it as 0 1 or whatever, it goes to the next number, and it causes an error in reading. So this is how we have to solve this problem. Thank you.